into solving by factoring, let's wrap up what we did yesterday a little bit. Okay? And we are going to record, so please speak loud. We put together two different groups. Can someone summarize the method you used in group A to find your solutions?
We had to find the zeros. Group A.
No, that's us. We did intersections.
So you graphed what?
We graphed both of the equations on each side, either side, and then.
Okay, so you broke the equation into two equations and then graphed them each separately on the same coordinate plane and found the what?
Intersection.
The intersections. So when you found the intersections, what gave you the solution then?
The x values.
The x values of the intersections, right? Good. Now group B, what did you guys do to find your solutions? Yeah.
We found the zero.
Okay. So
We graphed the whole equation, then
you graphed the whole equation.
we set it to zero. Set it to zero.
Oh, so first you changed the equation's form and rearranged it and set it equal to 0, right?
Yes.
Then you graphed that entire equation.
Yes.
So you just graphed one equation.
Mm-hmm.
Okay. Then what'd you do?
And then we found the zeros.
Where do you find the zeros at?
Where it crosses.
Where it, meaning the graph, crosses the x-axis. Good. And so then we talked a little bit, or you did in your groups, about what was the best way, the best method. This morning we actually had some people in favor of each group, and we didn't really talk as a whole class yet on that. So who all thought group A method was the easiest way to find the solutions? None of you? What did you find difficult about group A?
The fact that we had to graph two different graphs and then look for the intersection, and if the graph wasn't
So you had to graph two different graphs and then find the intersection. Was finding the intersection hard to do?
Yeah.
Yes.
Sometimes,
At
wasn't it?
first, until you showed
Way
it.
up.
We had to manipulate our calculator a lot sometimes, didn't we, to find the intersection. I shared with Mrs. Mills today how Maddie scrolled around on her screen to find the intersection a few times. And some of you did some creative things. Did you have something yesterday, Jet, that I said remind me of that today? I want to talk about it.
I told you.
It was the
It's a
last
tangent.
problem.
What was it?
It was the A cosine. When you mentioned it.
Oh, okay. That's something separate. We'll do that in a
I
minute.
told you to.
It was
to
D
remind
on
you
the
of
back.
tangent.
Yeah.
Right. We'll talk about that too. So anyway, when we graph each one, we sometimes struggle to find the intersection. How about when we did the, so I didn't see any hands on group A. So does that mean everybody agrees group B is the easier way to go? What makes it easier?
The calculator.
Though you used the calculator in the other problem though.
The fact that
But you only had the
do it like
zeros.
once.
It's easier to find the zeros than it is to find the intersection, so you don't have to keep scrolling to find it.
So why is it easier to find the zeros? You don't have to keep scrolling, but what do you mean by that?
Like the x-axis is right here, so they're all like on somewhere.
Okay, so they're always on the x-axis, aren't they?
Yeah.
So that makes it easier. Now we might scroll our screen in and out, right, our window, to make our graph wider or narrower or whatever, to get more of it in or to get less of it in, depending on what we need to do. But we still know that the zeros are always located where? On the x-axis. Okay? The book teaches method A. I teach method B. So you encouraged me that I teach you the easiest way to find. Did we accomplish the same task?
Yes.
Yes.
One way was just
More than one way of doing one thing, isn't it?
Mhm.
And you can choose whichever you want. Somebody first period said, I like group A method. That's fine. You can continue to use group A method. But you don't have to. Okay? Good. Now today we're going to learn how to solve by factoring. We already did the graphing yesterday. Today we're going to focus on factoring. That we already did. Here we go. Factoring sum and difference of cubes. I've already given the punchline away. Pump and muck. Two little words we use for acronyms to help us remember the signs. Notice that the letters AB are the same, A squared, AB, B squared, A squared, AB, B squared. They're exactly the same. The difference in these is what the signs are. And when I was in high school, I struggled to remember which was which. I got them mixed up all the time. When I got to college, I had a teacher who says, now, something easy to help you remember this, and he put these up on the board, and ever since then, for the last 27 years, I've taught this to every student that has ever had to factor sums or differences of cubes. Okay? So I'm going to pause now while you finish copying. All right, here's an example. Which model is it? The sum or difference? Difference. Is it written as a cube minus a cube? No. So probably the best thing to do would be to do that first. Let's start with the easier one. What cube gives me 8? 2. 2 times 2 times 2 is 8, right? What cube gives me 27x cubed?
3. No, it's not.
It's 3x.
3x. Yeah, I heard someone say 3 right away, but we can't forget the x. It's 3x. If I cube 3x, I get 27x cubed, right?
Yeah.
So now I have that model right there. It's all set up for it. This is equal to 0. So in the first set of parentheses, well, let's put the signs in them up. Notice that the acronyms, the first letter of the acronym is whatever the sign was. So when it was plus, when it was the sum of 2 cubes, it starts with a plus. When it was the difference of 2 cubes, it starts with a minus. Okay? Something to help you keep that part straight. Now, looking at this now, what goes in this first blank here? 3x. Because what went there? A. When it was a cubed, then it's just a. What goes in the second one? 2. What goes in the first one of the second set of parentheses? 3x squared. I'm going to write this. I'm going to take 2 steps to do what you might do in one. Because I agree, it's 3x, but the whole thing is being squared. You have to be careful. A lot of people leave the parentheses off and just write it as 3x squared. Okay? You write it this way. That is not the same as this. Okay? So don't write it this way. All right? What goes in the middle? 3x times 2. What goes in the last one? 2 squared. Okay? Now some of you might say, do I have to write that and show that step? No, you don't have to. But my experience is the more things you leave out, the more steps you leave out, the higher risk of mistakes you'll have. Yes, Tessa?
How says AB, how did we get 3x squared?
We did. We got 3x times 2.
Okay.
AB means the first term times the second term. And the first term was 3x, and the second term was 2. So you get 3x times 2 here. Okay?
Yeah, I did it.
All right. Now, let's simplify. 3x minus 2, I can't simplify that anymore. But what is 3x squared? 9x squared, right? And what is 3x times 2? 6x. And what is 2 squared? 4. Okay? Now, in this rule up here, all we're doing is factoring. We're showing you how to factor the sum of 2 cubes or the difference of 2 cubes. Down here, I'm asking you to solve. So we factored it, but we're not done yet. The reason we factored it is so that we can solve. Remember the rule? If A times B equals 0, then what's true? Either A equals 0 or B equals 0. Well, this is my A, and this is my B. Right? Parentheses group all that together, and I have something simple like A times B. So the only way then that this next statement can be true is if 3x minus 2 equals 0, or 9x squared plus 6x plus 4 equals 0. Alright? Jocelyn, can you solve this first one here? You tell me how?
Add 2x to each side.
Add 2 to each side.
Add 2
Yep.
to each side, and then divide by 3.
And then divide each side by 3. So get x is equal to 2/3. Right? X will be equal to 2/3. Now what brave soul has ideas to how to solve the second part? Yeah.
Minus 4. Throw in X.
Minus 4.
No, you want to keep it equal to 0.
Put it,
Someone saying keep it equal to 0.
put it in the X for, and you put in 2/3 for each X.
Oh. No.
No, you have.
No, this x 2/3 is why this part is equal to 0, but it's not going to be why the other part's equal to 0. That would be kind of a check. It wouldn't give me a solution. You know, what I'm saying is if I put 2/3 in for x, I wouldn't have an x anymore, right? So I wouldn't be solving for x anymore.
No, that's what I'm,
Okay.
nope.
Yeah, Obi-Wan?
Can you factor it?
Can I factor it? Good question.
That's what I was like.
Boy, it looks like it should factor, doesn't it? Guess what? It doesn't. You're right, it doesn't. If it factored, then this model would look differently up here. It would be already in factored form. Okay? So no, it does not factor. Boy, it'd be nice if it did. So it doesn't factor. I can't do what you're suggesting, Connor, because if I move the 4 over, I still have an x squared and an x to deal with, and I can't combine them at all. What method did we use to solve quadratics when we couldn't factor?
Quadratic equation.
Quadratic formula.
Isn't that the minus B?
Yep. So the second part of this, we say x equals the opposite of b, plus or minus square root of b squared minus 4ac all over 2a. Okay? So now, raise this up a little bit so I have some room. What's the value of A? 9. What's the value of B? And what's C?
4.
4. So if we plug them in, the opposite of 6 is negative 6. Plus or minus square root of b squared, 6 squared is 36, minus 4 times 9 times 4. Over 2 times 9. Four times A, which is 9, times C, which is 4. 4 times 4 times 9.
Do we not write down the, like,
You can if you want.
no, like, the x,
140.
Hold on a second. What's
like the
that?
x squared, or the x, can we not write that down? Like, would the x squared be after the 36, or the 6?
No. X and x squared are not part of my A and B. Those are the variables that we find A and B next to, but they're not part of it. Okay? So now, if I simplify that one little step in there I did not already do. And if I simplify that a little more, what's that negative, square root of negative give me?
The square root
Square root
of
of 108
108i.
There you
Oh,
go.
wait, or I.
And they'll probably write the I first. Now, some of you are going to stop there, and I've already told you, Mrs. Mills and I agree. It's not a big deal if you don't always know how to rationalize or simplify that in this case. But the rest of you are not bad at this, and you should continue to go. 108 is 36 times 3. And the square root of 36 is 6, and the square root of 3 is square root of 3. So square root of 108 reduces to this. Now why is that helpful?
Can this in 6 is
Because
equal?
6 and 3.
6 and 18 all have a what in them?
3.
A 3. No, they do. Yes, they do.
They all have a 6.
They also have a 6 in them, don't they? And they go in here once, and 3 times. And so the more simplified, the more appropriate answer that you'll find in the book is going to say -1 plus or minus I square root of 3 over 3. Okay? Doesn't make this over here wrong. This is just a more appropriate answer after it's totally simplified. Now all I did was I took 108 and I broke it down into 36 times 3 because 36, square root of 36 is 6, right? Square root of 3, I can't do anything with it, so I just leave it that way. So 108 turns in, square root of 108 turns into this, yes.
I don't understand why you put the 6i square root of 3.
Well, the book is normally going to write the I before the square root,
Right.
but it's also going to be after any whole number or integer.
Okay.
So they would write it as 6i square root of 3.
Okay.
That makes sense? If you wrote the I at the end and you just made sure that you put tail on there so it didn't end up underneath it, I'm not going to ever criticize that. Okay? Now, let's make sure you follow what I did here. This is a term, this is a term, this is a term. In order to cancel a common factor, it has to be available in every term. And so I have a 6 in here, a 6 in here, and I have 3 6s in there, don't I? So when I cancel this 6, I'm left with a 1. In this case, -1. When I cancel this 6, I'm left with just one I, or just I. And when I cancel the 18, I'm left with just the 3. Okay? If I didn't have that common factor in all 3 terms, I would not be able to reduce that final step. And again, as I said before, don't panic over this stuff here. If you don't get it, you don't get it. We've worked on it in Algebra 1, we worked on it in geometry. If you haven't mastered it by now, the odds are you're not going to master it. And so when it comes time for the SAT, what you're going to have to do is, if the answers look like this, you're going to have to, well, let's take the I out. Just say I had -1 plus or minus square root of 3 over 3. And you had -6 plus or minus 6 square root of 3 over 18. You work one of these out. Work one of these out, and you'll get the same decimal value. So you'll know which one's the right one. You know what I'm saying?
So like you could just call it.
Yeah, you just plug this into your calculator, use the +1, use the -1. You'll get 2 decimal values. Do the same thing with your answer choices over here, and you'll find that one of them is the same. And probably if the answer's there and you have this, you can kind of look at it and say, oh, that does look a lot like this, except this one has 1s instead of 6s, and a 3 instead of 18, that one has 6s and an 18, and there's factors of 18, all of them different, right? Okay, now, I showed you the right way to do this. I did not give you an opportunity to give input on how to solve. I just jumped right into it. I did that for two reasons. I want you to have a little more time today. Plus, I knew I would come back and show you the wrong way of doing this problem. Okay? So set your pencils down. We're going to do this problem now the wrong way, so don't copy anything down. The wrong way would be look at this and say, oh, Connor, what should I do first? Add 8 to both sides. Brett, what do you think I should do next?
Divide by 27.
Divide both sides by 27. Oops, sorry. Seriously?
Mm,
Was not this line the last thing I drew?
it was.
I can't believe it didn't undo that. Anyway. So I get x cubed equals 8 over 27. What would I do now?
Take the cube root.
Take the cube root. What's the cube root of 8?
2.
2. What's cube root of 27? 3. What'd I get?
2/3.
2/3. What'd I get up here?
2/3.
2/3. What else did I get up here?
-1 plus or minus I square root of 3 over 3.
Yeah, I also got this, didn't I? Or this one, if that's how you wanted to leave it. So what happened when I worked it out this way?
You only find one of the answers.
I only found one of the answers. How many were there?
2. 3.
3, right? There's 3 of them. I only found one. What was the degree of this polynomial? 3rd degree, right? It was a cubic, right? How many answers were there? 3. On all but one of the ones you did yesterday, how many answers did you get? 3. Right? If it's a 3rd degree, we're going to learn this in the next couple days. If it's a 3rd degree, you're going to find 3 answers. Sometimes, though, they're not all real numbers. See what I'm saying? Sometimes they're not a real number. Sometimes they are. Sometimes you have some of one and one type and some of another type. They're not always real. When you work the problem out this way, you get an answer. But you don't get all the answers. Also, later on, I'm going to show you how you could take this one answer, combine it with synthetic division, and then use what you get as a result from that synthetic division with the quadratic formula to find the rest of them. So there is another way of working this out and getting all the answers, and it might begin with this method. But if you think, oh, I'm just going to work this out like this and be done, you're only going to get 1/3 of the points because you only found one of the 3 answers. All right? So, let's look at this. I already graphed the blue line. You can't see it, it's hidden down here. The blue line is this equation. That's what we just did, isn't it?
Yep.
How many answers did we find? 3. How many of them were real? 1. Look where it crosses right here in the x-axis.
Yep.
So if I graph this, I would find the one real answer, wouldn't I?
Yep.
But the other 2 imaginary or complex solutions are not there. They're actually down here. My red graph is kind of in the way, but if I highlight that so you can see it. You see how there's a little crook right there in the graph? That's where the 2 imaginary solutions are occurring. Okay? I made first period graph that, and then I graphed at the same time, and it took more time than I wanted to take. So I want you to take my word for it. When you look at this graph, it's only going to cross the x-axis once because there's only one real solution. But down here, there's a little crook right here that little crook right there is because of the imaginary solutions that are occurring somewhere else in the graph. Okay? Now, the next thing I want to do is let's solve using quadratic form. So, copy this down. I'll give you a second to do that. Here we go. Again, I mean, we could spend all day with me quizzing you on how to do this problem. Until you've done it once, there's no way you would come up with it. Okay? There's no way, literally. So I'm just going to say, let's say a is equal to x squared. If a is equal to x squared, then what is this going to be written as?
X squared.
A squared, right?
Yeah.
Because x to the fourth is really x squared squared. And so this is going to be a squared plus 2a minus 8 equals 0. Do you agree with that?
Yeah.
I see some puzzled looks. Did I lose you?
A little bit.
Okay. Who said that? Okay. Do you agree that x squared squared is equal to x to the fourth? And if a is equal to x squared, then I could just put an a in here, couldn't I? And that's what I did, a squared. And then where it said x squared next to the 2, I replaced it with a.
Why isn't that squared then?
Because it wasn't x to the fourth here, it was x squared, and a is equal to
X squared.
x squared. So I just have an a there. Now I have something simple, quadratic. We factored, I won't say it thousands of times or hundreds of times. I have, but you haven't. But we did do it not too long ago, right?
Yeah.
The only way this factors is if we factor it like this. And what would the first blank in each one have to be? An A. What would my signs have to be?
Different. Oh.
Different. And then the factors of 8. Remember that? 1 and 8, 2 and 4.
So that's what it is.
Now because my signs were different,
You have to subtract.
I'm looking for the ones that subtract to give me
2.
2. And I want it to be a positive 2. So the 4 has to be positive. And the 2 then would be negative.
Is that a 0 at the end or is it?
Yep. It's a 0. When I'm recording, you guys don't see this much because I never record this period. When I'm recording, the computer runs so slowly that it sometimes doesn't keep up. I mean, I'll be finished writing a sentence and 4 seconds later it finishes that sentence. And it doesn't write very smoothly. Some of it is my old age and handshake, but a lot of it is just that. Now, we've done the hard part, the factoring. So what we do now is go back and say, wait a minute, we didn't start out with an a, we started out with x squared. Yeah.
Can you write down the formula for the factoring thing again? What goes where? Or is it now?
Quadratic form.
Well, the only way to
I have
get
it in my other note.
the only way to get a squared is if I have a times a. When this sign is negative, these signs have to be opposite.
Alright.
When that sign's a positive, they have to be the same as whatever this is.
Alright.
So if I had a plus here, then these would both have to be positives because that's a positive.
Alright.
All right? Are you with me? Okay. Did I go too quick on that factoring part? All right. Now, we didn't start out with A's, we started out with X's, so I have to go back now and say, wait a minute, it's not really an A, it's really a what?
X squared.
So this is really x squared plus 4, and this is really x squared minus 2. And we still use that same rule. A times b equals 0, then either a is 0 or b is 0. So in this case, either x squared plus 4 equals 0, or x squared minus 2 equals 0. now we can solve the way you like to solve.
Yeah, the easier way.
Move the 4 over. Then what?
On the square root.
Square root. What do you always get when you square root? Plus or minus. And because it's square root of a negative, what's that give me? I.
2.
And then what's the square root of 4?
2.
So instead of writing I2, I'll write 2I. Okay?
Got me all messed up.
Then we'll go over here. Add 2 to both sides. And then what?
Find the square root.
Square root. So what's x equal?
X equals square root 2 plus or minus.
Plus or minus square root of 2. Plus or minus square root of 2. Now, this, is that a real number?
No.
No. That's an imaginary solution. This one, is that a real number?
Yeah.
Yeah. So that's going to cross the x-axis, isn't it? So when I go back to this picture of my graph, and if I scroll up so you can see the x-axis, look at that. Crosses right there, and it crosses right here. See, the red equation is that one we started with there, isn't it? What do you think the value of that x value is right there?
2.
For negative 2.
Connor? You just looked at your paper, it's on there.
2. Negative square root of 2.
Negative square root of 2. What do you think the value of that one right there is? Positive square root of 2. So those two real solutions we just found are right there. Now if I use the calculator to find it, it's going to give me a decimal value. It's not going to tell me square root of 2 and negative square root of 2. Okay? Now if I scroll down, go back to where I was, what do you think's happening right there? Those are my two imaginary roots. Okay? Those are my two imaginary roots right there. Alright, so if we go back to this,
Wasn't that where our last imaginary one was too?
it was.
That's weird.
Yeah. Yeah. There is not a single spot where all those imaginary roots occur. Just so happens the two equations I chose here do. I'd like you to try this one. Okay? I'm going to pause for a minute so you can try that.
I like the graph.
I saw some good things. Let me do this real quick to make sure you're all on the same page. I have one more comment, and then I have 6 problems for you to practice on, and you can finish them tomorrow if you don't finish them today. But that doesn't mean we're going to waste time today. So a is equal to x squared. And so we end up with a squared plus 5a plus 6 equals 0. And then when you factor that, someone slow me down if I'm going to beyond the point you get distracted or lost or wrong, say something.
Plus and plus.
So I get a and a. Signs have to be the same as this, so they're both plus. If that was a minus, they would both be minus. Factors of 6 that add up, because the signs are the same, add up to 5 are 2 and 3. So then x squared plus 2, can I jump to here?
Yeah.
Equals 0. Or x squared plus 3 equals 0. I'm sorry, yes.
Oh, never mind. I messed that up.
Okay? So x squared equals negative 2.
Square root.
So when I square root both sides,
Plus or minus.
I have a negative, so it's going to be an I. But I have a square root, so that's always plus or minus. Square root 2 doesn't simplify. So x is equal to plus or minus I squared 2. I come over here. I get x squared equals negative 3. Square root both sides. x is equal plus or minus negative means I, square root of 3, can't do anything with it. Okay? Now, the graph looks like, my elbow kept getting too close to the board. The graph looks like this. I zoomed way in. Okay? I've zoomed way in. We're way up above. You can't really see it. To me, it looks like a little bit of a crook right in there. It's not real smooth. Okay? The reason I point that out is when you have an even degree, polynomial and you graph it, if all the terms are present, that graph is going to look like this. Kind of like a W. If it was a sixth degree and all the terms are there, there'd be 3 bumps in there. If it was an 8th degree, there'd be 4 bumps in there. Okay? All those things are occurring because of that even power. When it's just a 2nd degree, it's a nice smooth, at the bottom looks like that. It's a parabola. But the higher the degree, if it's an even degree, the more of this stuff you get going on at the bottom. The
So
more
you're
it
saying
flattens out a little bit.
The one with the 1 bump is 4th or 6th?
This would be a 4th degree
Yeah.
if it had lots of, if it had all the terms present. There'd be a little more of that waving going on down there. And then the higher the degree, the more of those you would have. Okay? And they might even do something like that. I mean, you really change things around, it'll change what that graph looks like. But another thing I wanted to point out, yesterday on that one that only had 2 answers, the graph looked something like this. And we found a real solution here and a real solution there. And I wanted to point out when the graph comes up and just touches a line like that, that's where multiple roots occur. Same thing we're talking about here. Multiple roots at the bottom of that. Multiple roots at the bottom of this. The higher the degree, the flatter this is going to get in here. You know what I'm saying? Or the more waves that will come on in here. Alright? The more of that kind of stuff will happen, the higher the degree. But when a graph comes up and just touches the line, that means multiple roots are occurring. If I go back to this, graph, and we look at that red one there, that's where the imaginary was, right there, right? Was just coming down and touching that, and so that's why we only got 1, but there's really 2 there, wasn't it? It was a plus and minus. There's 2 imaginary roots going on right there. Okay? All right. You'll learn this a lot more later, but those imaginary roots always have to come in pairs. Okay? So, today, if you look at your book, lesson 6-4, 13 to 25 odds. That gives you, no, I'm sorry, 15 to 25 odds. That gives you 3 of the cubes and 3 of the quadratic types. Okay? Now if you do those 3, and someone has to help you through all 3 of them, let's be mature enough to realize I probably need a little more practice. And do the others, or do some more, and find out, check the answers with my book. Make sure you're doing them right, okay? Probably don't have time to get them all done. We only have 15 minutes. But do as many as you can. 15, 17, 19, 21, 23, and 25. 15 to 25 odds.